Yeah.
So we have to.
See, lathe is trying to salvage anything and everything from there.
Oh no, you just my OCD's kicking in. I need to sort it all out.
You can.
I'm not seeing
So what's going on there?
So we're not having it connected. It's not. Be honest, just learning so much. Connected it straight to the table. I thought that would work.
The other thing about these is it's quite easy to take them out.
I'm mounting my feet.
Yeah, it's moving. It's just the wheel's not moving.
Wait, okay, so we're on the way. We're on the way. We're on the way.
Oh yes, that's the first one there.
Yeah.
You only need 8 of those to put a game on.
Oh, and then you use the alligator. Oh wow, this is so cool. Oh nice.
Thanks.
Yes.
But I can't get it.
Perfect.
Just having to think about it.
So are you getting this one?
It's better on the table. Uh-oh. Stop in.
Some really nifty tools that are made on the web and they're all free. So let's get started. So, let's see if this works. No, it doesn't. Yes, it does. Okay, so these are the outcomes for the day. And I think my main take from the outcomes would be how do you salvage material, because we know that most schools are on budgets, and especially in the middle of the year when you're trying to make a program and it's hard to get, let's say, $1,000 for doing an electronics workshop. How do you manage to pull things out from existing material by just looking around and seeing what's available, and how do you use them for your classroom? So those are some of the outcomes for the day. Remember, these slides and a whole bunch of resources will be shared with you along with that video that I'll put together. So what do cardboard circuits actually look like? And yeah, I mean, this is just the generic idea of how a circuit would look like. Traditionally, when you tell students we're going to do some electronics, in their head they could be thinking PCBs with green, boards and soldering and all sorts, but it doesn't need to be that complex. You could make circuits with the bare minimum, and it'll still be as exciting as it is with anything $100 kit or more. So, and I think the joy comes in making the kit yourself. It's the ownership that comes with when you make something yourself and see it work, rather than buying something pre-made and getting it going. So that's where the difference lies when it comes to cardboard circuits. What are we trying to combine here today is to get a little bit of coding and physical computing using the microbits. So some of you have got experience with the microbits, which is great. It's also known as a strand of physical computing, which also includes devices like Arduino and Raspberry Pi, if you have come across them. But the microbit right now is taken off because a whole bunch of educators around the globe have been supporting it and developing resources, and they've got this really cool competition called Do Your Bit, where they combine social initiative like issues in society and try and solve it using the microbit. So it's taken off really well, and we've got electronics or circuit making. So we've got to understand the science behind circuits. We might not be able to get into detail, but we'll do the basics good enough for you to take it back to your classrooms. And finally, the recycling or sustainability aspect of it. So that's why I was talking about the cardboard side of things and seeing what materials are available and how do you salvage it. And we are doing that against two important factors. One is interest and one is engagement. Now that's crucial with students, especially when you're thinking when you have students for an hour or 2 hours at a time, how do you keep that interest and engagement? There are two separate things, interest and engagement going over that span of time. You will get drops, but how do you get them back into it? And so we'll look at some ways in which we can tackle those issues. And so my journey begins at the local thrift shop. So I live in Waikanae, and I visit the Otahanga tip shop quite a bit. So that's where all the recycling comes into, and then they sort all the recycling out. And I spend quite a bit of my time going and shopping for things there. So for example, you know, I've been seeing these things, and I'll say, oh, that's got potential, and I'll just pick it up. It'll be like $1 or $2. But I can see that there's some motors in there, there's some cables in there, some electronics, which in my head I'm thinking there could be some useful components, although I myself wouldn't know exactly what's in it or how it works or whether it works or not at all. Yeah. I'm just going to pick it up, it's $1, I can salvage tires, make something else out of it, salvage the motors, do something else, maybe the cables, or for that matter, just give it to the kid and they will happily dismantle it for you. And that's another activity in itself. So that's my journey. I spend quite a bit of my time going to these kind of places rather than buying things at shops, you know, which cost hundreds of dollars. Why? So the next question is, why do I do that? Now, there's currently the rate at which we are going, we will come to a point where it's not going to be sustainable anymore to keep buying electronics, buying things, and just, you know, replenishing all of our natural resources. For example, when we go through like, you know, computers every couple of years, it's just like, oh, the software company has upgraded their software so much that it's not running on my hardware anymore. And that's what Apple has been sued for right now, because they always do that. They make their software so clunky that their hardware just won't work, and they make you upgrade their hardware, and that's how they keep making their money. Same with Tesla, you're not allowed to tinker with the Tesla, and people have been trying to take them to court to allow them to open up and fix their own cars. And I think the idea being that people want things to be a lot more repairable right now than it has been in the past is the key factor here. So, hi, come on in.
Buddy.
And I think also the fact, I don't know if you've heard about it, but Europe's leading the charge on trying to get a standard across phone cables. And they want to make all phone cables USB-C, because there is so much wastage with phone cables, because Samsung's got micro USB, someone's got USB-C, someone's got something else, and all these different cables are just, you know, once you discard your phone, these cables are just ending up in landfill. So they're trying to get a standard across Europe, at least for this moment, you know, try and for the next 5 years or something, keep one standard, and when the technology improves, you know, move on to something else. Of course, all the phone companies are against it, but you know, someone has to take the lead. With electronics, there are some basics that you need to understand, and when you look up electronics on the internet, there will be plenty of analogies coming up on your Google images and screens. One of the analogies looks like that. There'll be one where like someone's trying to hold a pipe and then someone's trying to push something through the pipe. And you could use analogies, however, sometimes they can cause more confusion among the students rather than, hello.
Hello.
Have a seat.
Hello.
Hi.
Sorry, mate.
It's all right. Grab a seat. Welcome.
Thank you.
Yeah, that's all right.
Welcome, was it?
Yeah. So yeah, analogies, plenty of them on the internet, and they can be tricky when you are introducing a concept to a student. So it's
Told it in glue just to
Go, Andrew.
What am I talking about?
Can you show us what you've made?
I've made a simple circuit here with a wee switch. So we hit the switch, the light goes on, switch off, and pull it back on. And what I learnt was that bulldog clips can short out at the back.
Thanks, Andrew. Brett?
I was part of the same thing.
We used to do this here.
That's good. You've got something going here.
Yeah, we added a little motor into the circuit and also had a slider to control the speed so we can slow it down or make it go faster.
Awesome. Well done. Thank you. Laith and Carmony, it looks like you've been working as a team.
Oh, what a team we've been. Yeah, we've been playing with lights and motors really, and making a connection and using the switch there. And yeah, we connected it all through the breadboard, and then we started looking at connecting it up through cardboard. And one of the problems that we were having was with this beautiful conductive tape, but the problem was getting a good connection. Like with the bulldog clips, we ended up putting the tape on the inside of the bulldog clips to make a. So it's kind of like if you run out of alligator clips. And what I noticed with this connection here, connecting a wire to the cardboard, is I folded the tape over itself, a little bit like you do with double-sided sellotape. Fold it over itself so it conducts on both sides. Because the sticky side isn't conductive, so you think you've got a connection, but you haven't.
Okay. Very valuable. Thank you. Okay. There you go, Joseph.
Are you sure? Sorry.
Well, I've had a go at making a car, but I think it works. So it works on the table, not on the carpet.
Look at it, guy.
Oh, come on. Don't let me down. I look a really... It's going to make me sound stupid, so maybe it shouldn't go on your movie, but I learned that I couldn't get it to work with one battery, and then eventually I thought, well, why don't I add more batteries, and then it worked. And you were all watching me fail doing that, and you could have said, hey, Joseph, add some more batteries, please. So that's what I learned. And I'm taking it home with me.
Awesome.
My cats will love this.
All right. You guys ready? Let us know what you've made.
So I've got a circuit here that I can press my on and off switch, and all the batteries are in series. What I really like is the fact that I can scavenge things and make new parts for my kit here.
Modular.
And so yeah,
Modular.
we'll be able to do that with the kids. So now when I plug in my new part, I can make it work, and it's very slow actually, this motor, bless it, but it is going round.
Yeah, I see it.
But if I plug this one in, it's much more exciting. So. She says, yes. So making the modular things is really cool.
Awesome. Thank you.
It's also tightly done too.
Hi.
So this is just a basic series circuit with a switch and your power source, your input if you like, and your output or your device on here with a light and a motor running in parallel. Originally I wanted to put, and sometimes you have to give the motor a bit of a tap to get it started. And that's basically what that was. Originally I was going to hoping to put a rear sat on it so I could show that and also have the ability to change it from parallel to series, but ran out of time, just to show the difference.
Thank you. Hey guys.
Hi. So mine is really just a simple circuit. I like this. It made me think of food, and then I thought about advertising food.
Nice.
And I thought if we could, because I do food as well, but circuits, advertising, making it like, hey, come to have my tacos, and just make it a bit more exciting. So just using the cardboard, but a bit more purposefully, because if we're going to have
Nice.
scraps, we're going to have cardboard sleeves and things. So that was just seeing how that works, and then. I found this brush and I was like, what do I do with it? So I tried to make it like a little doggy and trying to get it balanced, and it's supposed to move. Oh no! It was moving, it's meant to vibrate and move,
Give the
but...
wheel a bit of
Yeah.
Sometimes they don't.
Oh, it's connections.
There it goes.
So it's meant to...
Well, these bugs.
It needs a lead. That's what it needs. It needs a lead.
Oh, there we
Go.
go. There we
Oh.
go. You can see Crick, my little doggy.
Oh my god,
It's on its
kids
own.
would
So
love
it's
that.
wee size, but
I mean, they
Yeah.
would be beyond excited.
As a part of a whole rather than being isolated. So you're making circuits, you're teaching kids how to make circuits, but you want to try and make them think, oh, what is its value? Or try to make connections as to where you could use them rather than just, oh yeah, you've made your circuit, you've connected a few things, you've spun the motor, that's it, done. You want to see if you could connect it with something else and make a project. And this is where your cross-curricular connections will come in. So you could try and work with another teacher who is working on a separate unit and see if you could bring the technology and connect it to that aspect. So that's where you could do this next part. So, but before we get there, we've got a few things to learn about the technology itself. Now, this is a very short spiel because we're short on time. However, there's plenty of videos should you be interested to learn more. So the basic difference we want to know today to get started is microbits, what kind or what types. There's a couple, there's only two. And servos and motors, what other things you need to make them work, which are shields, and I'll introduce you to that. And then finally, let's look at a simple project that I was trying to put together and whether we can do something similar in that remaining last hour. And then finally, if we can make time, I'll show you the AI and machine learning platform for the microbit. So firstly, microbits. Now this came, the version 1 came a long time ago, and it's been very successful. So BBC has heavily invested in it, and they've gone to version 2s now. Now the main noticeable difference when you look at it are the clipped edges of the version 2. But apart from that, the shape and size is very similar. But there are plenty more features in the new version. The one that we're going to use today, if you have got version 2s, that's okay. If not, I've got a couple here that we can use, is the sound sensor. And on the version 2, there's a little microphone that detects sound, and you can program it to respond to that sound. So it detects the sound level, and then you program something to run. Maybe if you scream loudly, maybe a motor could turn, or a light could turn on, or something similar. All the other features like your temperature sensor, onboard temperature sensor, the compass, accelerometers, all of those are still there, but apart from that you've got the microphone, an extra LED as well, which helps you to identify when there's power running. That's the red power LED, and there's a yellow USB LED, so they are separated now. And also you can turn it on and off. So earlier you couldn't, it just plug and play, it just keeps going. Now you can reset, and there's a power button as well. So that's the advantage of it, having the new version. But looks-wise, it's pretty much the same. So you wouldn't, yeah. There we go. So that's the basic difference between the two microbit versions. Now the microbits itself are made to connect with interface with basic LEDs. However, when you want to connect with high current drawing things like motors, you need to add on something called as a shield. So that's this little add-on that comes, that you slot the microbit in, and then you've got multiple outputs that you can connect things to. For example, a motor, or well, in this case, there's a motor shield, so you would connect a motor. There are other things. For example, here we've got a servo shield. So this little here, shield here, talks with servos, which are these units here. It's essentially a motor, but it's geared down so much that it really drives quite slow. And they've got high torque, so you could, make things move like gears and stuff.
Electronics question. Could you just use a transistor instead of a shield? What was a shield with a transistor?
It's well protected, the shield. So in case of misconnections or something like that, it's quite protected on board itself. So nothing would blow up accidentally if you connect something wrong. However, you could make your own shield if you wanted to. There's nothing stopping you from making your own shield. But the advantage of these kind of things is that the microbit slots in, and each of these pins are programmable. Then you can put your jumper pins in and make them do whatever you want them to do. The Servo Shield connects with the crocodile cables, which are these ones, right on the gold connectors, which connect straight to the microbits, and you can connect up to 3 servos. And then you need to power it externally. So the microbit itself supplies 5 volt power, but it might not be enough to drive all of these additional components. Slow me down if I'm talking too much, because I know it's quite a bit of information, but the basics are you've got microbits, which are programmable devices, and they've got a few sensors on them, but you can add a lot more to it by interfacing one of these things. That's the do long, didn't listen.
Question.
Yep.
With the shields, you've already mentioned 2 kinds. I mean, are there
There's
4
hundreds.
of them? Right.
There's quite a few. So each shield has a specific purpose. So for example, this one drives motors. There's ones for servos. Here we go. Another one coming up. And what people have done, or what companies have done, is made their own shields. So it's very specific to their make and model. So this one, made by Elicro, this company, has got its own connectors. So it's very proprietary to that model. You've got a kit which is, it's the same make. And it's got, so its connectors are proprietary to that make and model. So it'll be harder for you to interface something else. However, it's got those gold connectors which you can plug your crocodile clips to, and the microbit slot. All of these shields do need an external power. So that's the next thing you've got to think. How would you connect some external source of power, maybe a 5 volt, up to 12 volt, that is, you can connect a 5 volt power pack of some sort. So that's one, and then with that comes a whole bunch of other things that you can add on. For example, like in this kit, I'll just show you from here. There's tons of sensors. So for that specific shield, you can add LEDs. There's a temperature, humidity sensor. There's a OLED display. There's a soil moisture and humidity sensor. There's one of these sliders for potentiometers. A speaker, ultrasonic. Yeah. So you can get all of these kind of add-ons. And there's numerous. There's ones, so if you look at the back of the room, there's a little core fluid box that I've made, and that is like, well, it's meant to be a greenhouse. Inside that is an IoT shield. So the microbit slits into this shield, which is connected to the internet. And what it does is it relays data from that box onto a web interface, and I can see the temperature, humidity straight onto the web. Whereas with a regular microbit, you won't be able to do it. So every shield has its own use case. Depending on what project you're trying to achieve with the kids, you might need a range of these tools. However, just with a basic microbit, you could go a long, long way. So I've got a whole bunch of resources on the end. If you go through them, you'll see people have made tons of projects that you could easily get through 5 weeks of work with the students without having to even buy any add-on. Any questions? Okay, so that's the basics. Now, interfacing what you have made with the microbits.
Is that right? Is that right?
These things here?
The advanced that we bought in the server transition.
Oh, yes.
All those things on the page, basically subroutines.
Yes, yeah. It's all abstraction done for you. It's all hidden away, just so that it's convenient. Yes.
Can I get a shield?
Yes. Sure. Right. Next. The next thing is the connections. So you're literally ready to go. All you have to do is hit download, and it should download to your microbit. However, there's a few things that you might want to check. For example, the connection. So the first thing we'll do is make a connection between the microbit and your laptop. So click on these 3 dots here. 5 minutes. It's 10 minutes until your wrap up time, or if you want to start wrapping up now. But I'll just quickly show you again. As I said earlier, the resource is on the PowerPoint, and I'll shoot it off right away once you're done. So this app here is a free app for the microbit. It's called Plushpal.app. It's a web-based software for doing AI and machine learning concepts. Now it was made by a researcher, and she did it for some outreach event. And here now we've started using it quite a bit. All you need is a microbit. It works over the web, so you don't need any additional like tools as such. It uses you pair your microbit up. So once you plug your microbit in, actually this won't work now because I've got this going. Oh, sorry. Before that, what you need to do, sorry, I forgot to mention this. If you scroll down on this page, before you begin, you need to save this firmware. So you download the firmware onto the microbit, and then it detects it. But what it's using is the computer's camera to do some recording, and then you can respond by doing things on the microbit. For example, the microbit has got a shake thing, like when you shake the microbit, it responds to that. It's got some sensing on it, and you can respond to certain events, but it's using the computer to help you with that. I wonder if there is some examples here that I could quickly show you, but quickly just drag and drop that. So it's that file there, plushpal.hex. And what I need to do is drag and drop that over, so that's where it is in my downloads. So drag and drop that into the microbit, and your microbit starts to flash quite rapidly, so you know that the file's being file's going over. Once it's done, you refresh this page and hit pair your microbit. There we go, it shows up, and then I hit pair. It says connecting. There we go. So now I've got the microbit's details in real time. So it's detecting a bow, and when I shake, it's detecting the shake as well. And this is the real-time data. And why is it making that sound? That's because the trigger here is when on shake starts playing wow, and on bow it starts to upload. But I mean, you can customize those sounds by hitting that and say whatever else you want it to say. You can record sounds or upload and do text to speech and all sorts of things. So it's a lot more to tinker. We won't have time, but it does detect volume as well. And what else can you do with it? Oh yeah, this is how you integrate it. So this is the important part. So the idea being that you're integrating soft robotics using, let's say, one of these, which have got some movable arms, so you could get an animal or whatever, get the student to pick their own toy. You sew the microbit in a little pouch and put the microbit at the back of the toy, and then you start to interact with it, and then it starts making the sounds. So that's the idea. So you're integrating the toys with the AI machine learning platform using the microbit. So that's how you could take it forward from the electronics. So you're starting to look into further concepts of AI and machine learning. There's one project that you just saw, which is the RC car, and that's how you interface some electronics with the microbit, and you can program it. I have a complete tutorial for it on my blog. So it's the RC car hack. So here it's the same car here that I've used, and I've given a sort of step-by-step on how you go about doing it. I don't have a lot of pictures, but I've got the code just in case you want to copy and paste that code. It should work right away, and that's it working there. So, and there's a few troubleshooting things as well. But this is how this is one way of how you could interface certain hardware like motors with the microbit. And these aren't specific kits I've bought. These are just direct motors from an RC car that I've used as is. So that's what I was trying to explain earlier about how you could use some of the electronics you made in the circuits to work with the microbit. Of course, as I said, you will need some sort of add-ons like the shields, because they won't be happy to work directly with a microbit. It just won't work, or it might blow it up. The motors draw a lot of current, and the microbit won't like it. So you need those shields. But there are plenty of these projects on the web that you can have a play with, and see if you want to venture out in that direction. So that's all from me. Any questions? So I'll send you the PowerPoint. Lee's laughing already.
No, I was going to ask, not only is this is your day job, Prev, is this what you
Playing
do
with toys.
Is this what you do for fun as well?
Yeah. No, I was looking forward to doing this because we haven't had many sessions like this in the last year or two. So it's good to connect with teachers and hopefully share some ideas and see them being used in the classroom. On that note, thanks.
Prev, look, I've had a great day. I've learned lots. I really enjoyed playing.
Thanks for coming along. I appreciate it. Please feel free to sing out anytime you want a hand. This is my job, so I'm happy to come out in case you get stuck while doing something like this. I'm happy to come out. You'll need to give me an advance notice. Show up in the morning, say, hey, I need you to come to Marlborough. But I'm more than happy to come out to your schools and help you out with projects. And as I said, the resources as well, I'd be happy to share. If you've seen something useful and you think you want to use that again, let me know. We're happy to lend it out. But with your cardboard circuits, what you have made, you're welcome to keep. And I'll take the Servo Shields back as well, run another session, and the microbits again with some more teachers. And lastly, there was one, I think some of you are intrigued by the kits, the packs itself which are made. But these were made to go with this resource that's called Easy Electronics by Charles Platt. So he's a very good author for electronics. He's made a lot of advanced manuals as well, but this is the most basic one. This should take you easily from 3 to 5 weeks of doing electronics. So it starts from series and parallel circuits, goes into transistors, resistors, capacitors, goes into ICs using a 555 circuit, so automated circuit, timer, and then there's the advanced version of the book. And these kits are easy to make. You just buy the components in bulk and then put them in nice little flat wrap bags.